First thing, waves, right? What we are actually talking about. When we were talking about the waves, as I told you previously, in case of light especially, the initial time it was a thinking that it wasn't a wave, but it was a particle because it performs reflection. Then it performing the refraction as well. Then we have done the diffraction and everything. Then scientist Einstein came in and he said that light is not a particle, not a, you can say wave. It's a packet of energy, right? Which we will be talking later on because there are some phenomena other than the photoelectric effect, which are part of our syllabus as well. But for the time being, what is meant by reflection, Zoha?
When light is reflected
You
off
can say
the
bounce.
surface.
Now, this is very important thing. When light bounces back into the same medium. So, bouncing back of light into the same medium is called reflection. Now, very importantly, when you say bounces back, it means that light comes into the same medium. My point is, Zoha, at the time when you are studying reflection, does light only do reflection? No refraction take place?
It also reflects.
Some light will be refracted, and definitely some light will be reflected as well. At the same time, reflection and refraction take place because we study reflection. So we are talking about reflection. But definitely, reflection and refraction occur at the same time. Okay. Some light comes back into the same medium and some light goes into another medium after passing from one medium. That's what it means. So we know that few things. The light which is actually, you can say, strike the medium boundary. What do we call this light?
Um,
Incident ray.
oh, that's right.
And the ray which comes back, we give it a name called reflected ray.
Reflected.
And the ray which seem as a dotted line, we give it a name called
Normal.
normal. So these are the three rays we are talking about in reflection. There are certain laws, but this light ray has to obey. If they are not obeying those laws, it means it's not a reflection. What are those laws? Number one, incident ray,
Um, the
normal,
incident.
and reflected ray all lie in the same plane. And the second rule is or law is, what about this angle here? This is the angle between
The
normal
incident
angle of incidence.
angle is equal to angle of reflection.
Yeah. So angle of incidence must be equal to the angle of reflection. These are the two laws. Your all the details or your normal reflected ray and all these should obey. Otherwise, they are not performing the reflection. Okay. Understand that this is what the reflection is all about. Now, which device or which optical instrument is used to have a reflection? Normally, it's a mirror. We do have mirror with that, and mirror will do this particular thing. My question to you is, if mirror does this, it means that always whenever you have the reaction, I mean, whenever you have the reflection, mostly it is from the mirror, right? Now, let's talk about refraction here. Refraction means passing of light from one medium to another medium. For that purpose, what do we have? There are different devices we have it, but the mostly what we use is called lenses. The proper definition and the proper details of the lenses will be in the second part, I mean in A2. If you come to me in A2, I will let you know how these lenses will work and how each and everything will be sorted. But in here, we will see how the light will go from one medium to another medium.
Okay.
Now, remember that there are two type of mediums when I talk about mediums. So there are, just write it down. There are two type of mediums. There are two types of medium. One medium is called as denser medium. The other one is called as rarer medium.
As rarer,
Yeah, dense.
rarer medium.
You're saying something?
Okay.
Okay, denser medium and rarer medium. Remember that these are relative terms. What do you mean by relative terms? I can give you an example. Let's suppose you are comparing air with water. So, which medium is the rarer medium and which medium is a denser medium?
Air is rarer, water is denser.
Yeah. What if I compare water with a glass now? Now tell me which medium is rarer and which medium is denser?
Glass is denser, water is rarer.
Now do you understand what do we mean by this relative terms? Whenever you're comparing two mediums, then these two terms will be used. Okay. You
Okay.
can't just say one medium as a properly denser medium forever and one medium is a rarer medium forever. It's always a relative term. Whenever you talk about it, you have to talk about them in relative to certain other medium. Okay.
Hmm.
So, so now put a heading denser medium. Just write few lines. A medium in which particle of the medium are close to each other. Particle of the medium are close to each other. Now put a heading rare medium. Write few lines here. A medium in which particle of the medium are far away from each other. Are far away from each other.
Okay, done.
Okay. Now, once you understand which one is a rare one and which one is a denser one, now you need to understand few things. Let's just put a heading. When light goes from rarer to denser medium. When light goes from rarer to denser medium. Let's suppose this is your denser medium and this is your rarer medium. This is the boundary of the medium. And what is this line?
The normal.
The normal. Let's suppose this is the light which is coming here. What is this thing? This is called angle of incidence. Whenever light goes from denser to rarer medium, remember that it bends towards the normal. Just let me just draw it properly so it will be much more easier to understand. Like for example, if this is your angle of incidence, then it will bend towards the normal. This is your angle of refract. No, sorry. When it goes from denser, what did you write? Denser to rarer medium or rarer to denser medium?
Denser to rarer.
Denser to rarer. So it bends away from the normal. Or you can say that angle R will be greater than angle I. Understood?
Yes.
When light goes from denser to rarer medium, now I want you to first draw that diagram. These are the straight lines because I have a pad. That's the reason I can't do that. But you can try that. This is a line as well as this is a line. But it bends away from the normal.
Okay, done.
Okay. Now write few lines. When light goes from denser to rarer medium, when light goes from denser to rarer medium, Light bends away from the normal. Light bends away from the normal. So what about the speed of light and the wavelength of light? What happened to them? V is
Can
equal to
can
frequency
I say
number.
one thing? Can I say one thing?
Yeah, bends away from the
Um,
normal. What about
you
velocity and
said
the lambda?
um bends away from the normal, so the velocity increases,
You can
so the
take and
wavelength
see,
increases.
I can give you a very simple example you will be understanding. For example, Zoe, you're driving a car, right? And you are in a traffic jam. Suddenly traffic jam finishes. What do you think? Your speed will increase or reduce?
Reduce.
No, no, you have a traffic jam. Not traffic jam, you're stopped, right? Suddenly traffic jam
Mhm.
finishing. As soon as it finish, your speed increase or reduce?
Increase.
Increase. So same thing is a in a denser medium, you are sort of a traffic jam, right? As soon as the traffic jam reduces, I mean finishes, your speed will increase. And because V and lambda are directly proportional, lambda is also increasing as well. So, so the
The
velocity,
wavelength
yeah,
increases.
so the velocity of the light, so the velocity of the light and wavelength of the light also increases.
Okay,
Okay. Now write one more thing. Angle R should be greater than angle I in that.
I read that.
Okay. My point is, what about this frequency? I didn't say anything about the frequency.
So reduce.
Remember that frequency stays the same because it depends from the source. Frequency never changes. Frequency never increases. Frequency never reduces. It stays the same. It's a constant quantity.
Oh,
Okay. Only V and a lambda increase or V and lambda reduces. So, Zoha, what are the two things happening once you go from denser to rarer medium?
the angle of refraction will be greater than the angle of incidence. Um,
Light bends away from the
Naturally,
normal,
yes, light bends away from the normal
and velocity and
and
lambda value increases.
reduces.
Now, the second case, when light goes from rarer to denser medium. For that, now the diagram is, let's suppose this is your angle of incidence. When light goes from rarer to denser medium, it bends towards the norm. This is rare, this is denser. Draw this diagram. In that case, angle I will be greater than angle R. Zoha, this recording, if you want to see, I will place this recording same there in the same,
The
same,
Google Drive.
yeah, yeah. I will put this in the same, I mean, uh, folder, but definitely I will put the name on that. Zoha, not Zoha. I will just put unit 2. That will be easier for you to find out. Okay.
Okay,
Because this is your unit 2, right?
yes,
Okay. So I will put it like this. So that will be easier to find. If you want to go through this again, for example, by any chance, then you can simply find out unit 2, and then I will write the topic name, and same thing will be going like that, right?
fine.
Or what I will do, I will make a folder inside that, and you will find unit 2 and you will find the recordings. Okay.
Okay,
Okay. Now what happened? Did you draw it already?
yes, I did.
Okay, now write few lines. When light goes from rarer to denser medium, when light goes from rarer to denser medium, it bend towards the normal. It bend towards the normal. And the speed and wavelength of the light and the speed and the wavelength of the light reduces. Reduces. Right on the corner. In this case, angle of incidence is greater than angle of refraction.
Sorry, it suddenly disconnected.
No problem. You're back?
Yeah,
Okay, that's all. So now, if you understand refraction, any problem in this?
no, no
Okay,
problem. Yes.
good, good. Now, there is another thing which is very, very important at this point is that is called as Snell's law. What Snell's law is saying that sine of I divided by sine of R will always be a constant quantity for a particular medium. Remember that. Always for a particular medium. And that value which is constant is called as refractive index. So what do we call it?
Okay.
Snell's law is saying that angle of incidence divided by angle of refraction, and that is a constant quantity.
Hmm.
Okay. Now at
There's
this
also
point,
one
yeah. Hello.
1/sine. I'm not sure if I remember.
Yeah, just a second. I'll show you this one. Then you will understand this. This is the one. Snell's law is saying
Hmm.
sine I upon sine R is a constant quantity, and we give it a name called refractive index.
Hmm.
Now, this is very interesting fact. Why I'm saying this? This is interesting. Actual formula for the Snell's law is this one: n1 into sine theta 1 is equal to n2 sine theta 2. Where this formula comes from, that's what I'm giving you the hint. N1 means a refractive index. What exactly it is, I'll let you know. Sine theta is the angle of incidence. N2 is again a refractive index, and that is your angle of R. Now, interesting point is because light goes from air to water, right? In this case, if you just check this out, in this case, light goes from water, air to water. It means from rare to denser medium, right? So
Right.
we consider refractive index of air as 1. So this one is equal to, this is your refractive index of the second material.
Okay.
So if you want to find out the refractive index of water, for example, you will use this formula. So basically, this is the formula, we have it. And this formula will be converted into this formula. N2 means refractive index of water. Remember that
Okay.
this formula will be only and only when you are comparing air and any other particular medium. Let's suppose water, glass, or whatever. This is the formula when you use it. But actual formula is this. N1 sine
Okay.
theta 1 is equal to N2 sine theta 2. Theta 1 is angle of incidence, theta 2 is angle of refraction. And this formula always work when you are going from rarer to denser medium.
Hmm.
Okay. So I want you to write few lines here. When light goes from when light goes from air to any other medium, air to any other medium, the refractive index of that medium, the refractive index of that medium can be found out by sin I upon sin R. Sin I upon sin R.
Done. I read it.
Okay. Write few further lines where sin I is the angle of incidence, where sin I is the angle of incidence of light in air, and angle R and angle R is the refractive index, is the angle of refracted ray, and angle R, sorry, and angle R is the angle of refraction in that particular medium, in that particular medium, whose refractive index needs to be found out.
I finished writing.
Okay. Now, important thing is this is easy. If you are comparing any refractive, I mean, if you are comparing the refractive index of water with the refractive index of any material, right? But if it's not air and, for example, water, or if it's not air, instead of air, it's water and glass, or if it is two different glasses, then you have to use this formula, which is N1 sine theta I is equal to N2 sine theta 2. It will be like you will put a refractive index of the first material, the angle of incidence of the first one. That one will be the refractive index of the second one, multiply by the sine of the theta 2. This will be angle I, this will be angle R. This is the generalized formula for Snell's law. Okay.
Okay,
Just write this formula.
I wrote it.
Now there is another. Now, what exactly has a significance of refractive index? For that, we have another formula. Speed of light in air or vacuum divided by speed of light in medium.
Okay. Um,
Speed of light in air or vacuum divided
it's just
by speed of light
um,
in medium.
so for speed of light in air vacuum will it just be 3 times 10 to the power like to the power 8.
Yeah, this is the standard one which we are taking. 3 into 10 raised to power 8 meter per second. Now, interesting fact.
Okay.
If you see the formula here, what do you expect? What will be the value of reflective index of any material? Can this be less than 1?
Mm, yes.
No. Remember that the
No.
value of refractive index can never be less than 1. The reason is numerator is always the greatest because the speed of light in air is the highest speed. Speed of light in a typical medium will always be less than the numerator because as you are taking
Okay.
different mediums, the speed of light will be lesser and lesser and lesser depending upon the denser, I mean, denser or a bit rarer medium or less denser or more denser medium. So speed of light in a medium will always be less than the speed of light in air or vacuum. So your value should always be greater than 1.
Okay.
But remember one thing, if it's very much greater than 1, I mean, let's suppose if the value is coming 5, 10, 20, or something like this, it means that material, that medium is not good medium because it is not letting the air light passing through, or it's a pure hard material, or you can say maybe not a good conductor, exactly a bad conductor being. So normally this type of I mean, materials which have very high refractive index, we normally don't consider them as a window, especially. You should have a good refractive index ones like 1.15 or 1.25 or 1.45 will be good, considered as very good one. I don't know you ever see those windows or not, in which you can see from outside. I mean, you can see from inside out, but nobody can see from outside in,
My head has those windows.
right? So, in one side, their refractive index is less. From the other side, the reflective index is more, so that nobody can see from outside. So, did you see the significance of this refractive index? This is what the refractive
Yes,
index significance. Okay. So, this is the formula which comes from uh, refraction. Okay. Understood?
I understand.
Any questions?
Yeah.
All right. Now, once you understand that, now a very small topic related to this all reflection and refractive index and everything. It's an interrelated topic, and that topic is called as total internal reflection. Sometimes we call it TIR. Now, what is meant by total internal reflection? That is my point. Now, what is meant by this? Let's see. By the way, symbolically, the same thing which I just told you, speed of light in air, we take it as c, and general velocity will be taken as v. So the formula for the refractive index is n is equal to c upon v, where c is a speed of light in air and v is the speed of light in that particular medium.
Okay.
Can you solve that question for me, please? This one. What is the speed of light in a medium with a refractive index of 2.4?
I got 1.25 times 10 to the power. Um, it
8.
says 8, yes.
Okay, that's fine. Absolutely right. Now, there are few things which are very, very interesting in total internal reflection. Okay. For this, you need to understand two things which are very, very important. The first thing first is total internal phenomena will occur, or you can see that one when light goes from denser to rarer medium, not rarer to denser medium. Whenever light goes from denser to rarer medium, then and only then this phenomena occurs. Otherwise, don't. Okay. Now, what exactly it is and where do we use it, you will find out in a few minutes. First thing first. When light goes from denser to rare medium, what happened? Light bent away from the medium. Am I right?
Yes.
Now, let's suppose this angle of incidence value is 20 degrees. Let's suppose it. So, my question is, if I increase this value by, let's suppose, 23, what do you think? Angle of refraction will also increase?
Yes.
So, let's increase it a bit. What if I further increase this angle of incidence? One time will
I
come
think
that angle of refraction value will be equal to 90 degrees. Am I right?
it's a angle will occur.
So basically, I am increasing angle I and I increased angle I to a point while angle of refraction value is exactly equal to 90 degrees. Right?
Okay.
Let's suppose that value is actually 25 degrees. What if I increase the angle of incidence by 25? Let's suppose 26.
Uh,
What will happen now?
it will reflect.
All the light ray are actually reflecting into the same medium. And no light will be refracted into another medium. So in this case, all the light reflected into same medium and no refraction take place. Refraction not taken place. So this phenomena in which all the light ray reflected back into the same medium and no refraction take place This phenomena is called as a total internal reflection, and this phenomena is employed in fiber optics communication.
Okay.
Do you understand?
So
Okay.
yes.
Now I want you to write, because now we have to write this. Put a heading: total internal reflection. First point: when light goes from denser to rarer medium, light bends away from the normal. I want you to draw this diagram, please. Okay. Once you draw it, let me know, please.
I am having a really bad connection. I disconnected again.
Okay, it's fine. Just draw this diagram, please.
I drew it. I
Okay.
will do
Then,
it.
in a second bullet point, if we keep increasing angle of incidence, if we keep increasing angle of incidence, the light ray, the refracted ray will further bend away from the normal, will further bend away from the normal. So the angle of refraction, so the angle of refraction also increases. Yes, Alicia, how are you?
Fine, thank you.
What happened? Everything okay? You just joined?
Oh, don't we have class right
Mm,
now?
No, no, it's a class with Zoha, not with you.
Oh, wait, so when is ours then?
Our timetable is the
Like,
same.
so not on Sunday?
Yeah, I think we have a class in the yeah. Do we have a class today or not?
Yeah, we're
No,
supposed to have class like right now. Like,
no, we don't have it. Your timetable is the Mahnur's timetable, right?
oh, okay, nice.
So
So
it's
it's
not.
like completely Mahnoor. It's not shared anymore.
No, no, this is Zoha's class, because
Oh,
he's
okay.
taking one paper, right? So
If
it's not
if
Yeah,
your.
guys are doing unit one, I'm still doing unit two.
yeah, okay, makes sense.
Okay. So it is
Okay, bye.
your class is only your class is scheduled with Mahnur's timetable, right? It is like
Okay,
evening, 10 o'clock, 10 p.m.
yeah,
Okay.
okay,
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 no
bye.
problem. Okay. So if you keep increasing angle of incidence, the refracted ray will be further bent away from the normal. So angle of refraction also increases. I want you to draw this diagram now.
I drew it already.
Okay, you drew it. Okay, now in the next bullet point, if we further increase angle of incidence, if we further increase angle of incidence, one time will come, one time will come that angle of refraction will be equal to angle of refraction will be equal to 90 degrees. I want you to draw this diagram.
Then
Done. Right in the next bullet point. If we further increase angle of incidence from this point, if we further increase angle of incidence From this point, no light will be refracted into another medium. No light will be refracted into another medium, but all the light, but all the light reflected, reflected into the same medium. All the light reflected into the same medium. I want you to draw this diagram.
I did it.
Done? Okay. Now, this whole summary, we will come and summarize this. Next bullet point, the process of reflecting back of the light, the process of reflecting back of all the light into the same medium, into the same medium, into the same medium at an at a value of angle of incidence, at a value of angle of incidence more than, at a value of angle of incidence more than the angle, the critical angle, more than the critical angle, more than the critical angle when when light goes from when light goes from denser to rarer medium, when light goes from rarer to denser medium, is called total internal reflection. Is called total internal reflection. Zoa, did you copy?
Yes, done.
Next bullet point, please. A value of angle of incidence, a value of angle of incidence at which, at which angle of refraction will be equal to 90 degrees, at which the value of angle of refraction will be 90 degrees, is called critical angle. It's called critical angle.
I wrote it.
Okay. So we'll finish our class here. Inshallah, we will be continuing our class from here next time. All right.